In this video we will solve a problem on torsion again. Okay, so this is the sixth problem here. In the previous video also we solved problems in different varieties here. Okay, so this is a type of problem, and we'll read first and then we'll solve here. Okay, so I'll read the problem here. So a 60 mm diameter shaft, the diameter of the shaft is the 60 mm, it is a solid, is subjected to the torque at various sections as shown in figure. So here this is the solid shaft, its diameter is 60, it's d equal to 60 mm, that is data. I'll write here. So data, diameter of the shaft equal to 60 millimeter, subjected to the torques at various sections. If you see the picture here, the at A, B, C, D, there are 4 sections are there. In the A point, it will be subjected to some torque of 2 kilonewton meter. In the B point, C point, and D point, in all 4 points, it is subjected to the torques of different values here. Okay, at various sections as shown in figure. Determine. First, we need A, the total angle of the twist. For related to this, what is the total angle of T total, the theta total angle of twist equal to how much we need to calculate. Okay, next the B bit, maximum shear stress induced in each section, in this section, in this section, in this section, in this section. You need to calculate the maximum shear stresses in each section, how much, that is we need to calculate here. Okay, so first we'll go to the A bit, how to calculate the angle of twist, total angle of twist. Then we'll go for the B bit here. Okay, so I'll go for section A. If you want to calculate the angle of twist, first we need to find out the torque in each section here. In each section, we will draw the torque, the turning moment diagram here, turning moment or torque diagram in the whole the solid section. Then we'll calculate the one by one here. Okay, so first the torque at portion AB, this is AB, right? AB. So this is clockwise and this is anti-clockwise. Clockwise we will take it as negative, and anti-clockwise we will take it as positive here. So this is 2 kilonewton meter, it is clockwise, so I'll take it as minus 2 kilonewton meter. Okay, if I take the if I draw the diagram from here to here, this is the reference line. Okay, this is the reference line. So minus 2 kilonewton meter. Okay, so this I'll go here, from here to here, minus, from here to, that is minus 2, here minus 2, and up to B, this is the B portion. This is C portion and this is the D portion here. Okay, this is minus 2 kilonewton meter torque. If you go up to the B point, the same torque it will be acting. Here this is minus 2 kilonewton meter. Okay, so at B, torque at B, how much is the torque at B? Up to AB it will be minus 2. At torque at B, minus 2 plus 1 here, because this will be this is clockwise, this is counterclockwise, that is minus 2 plus 1 kilonewton meter, that will be equal to minus 1 kilonewton meter, right? That is minus 1 kilonewton. So here at B it will be minus 1 kilonewton meter, right? So from here to here it will jumps to here at B. Up to AB it is same. At B it will be changes. Now go to BC portion. Torque at BC portion. So now up to the BC it will be same, because the same here it will be acting. That is minus 1. Kilonewton meter. So up to BC, the same. This is -1 kilonewton meter. Here also same, -1 kilonewton meter. At C, if you go at C, how much it will be there? Torque at C equal to -1. This is -1. Next again, this is the anti-clockwise. You have to take it as plus. That is +3. +3, right? +3. So that will be equal to 2 kilonewton meter. At C. BC it is same. At C it will be changes. It will be 2. So it will come down +2. It is +2. Here 1, here 2. At this is 2. This is +2 kilonewton meter at C. Next, CD it is same, because this up to here this is the same. It will be acting. CD it is same. Torque at CD it will be equal to 2 kilonewton meter. Same. 2 kilonewton meter. So from here to here it is same, 2 kilonewton meter. At D, torque at D. Torque at D, how much we are getting here? It will be 0. 2 plus 2 here. That is 2 minus 2. 2 minus 2, it will be 0. So it will come down here. It will come down. So your torque diagram is, it starts here, 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 and here to go. That is -2, that is plus -1, +2, and 0. So this is the torque diagram. Okay. Now once if you calculate the torque at AB and BC, CD, BC and CD, we will go to calculate the angle of twist. That is the first bit. Okay. Just okay. So first we will calculate the angle of twist one by one here. What is the formula? That is T by J equal to G theta by L. G theta by L. This is the general formula for the torsion. So from this we can calculate the theta. Theta equal to how much? Theta equal to L into T divided by G into J. G into G. So now we will calculate the angle of twist in each section. Each section. Okay. First I will calculate the angle of twist B with respect to A. Here angle of twist B with respect to A equal to length of AB, right? Length of AB into torque AB divided by G into G. What is the G? Is given in the data. Just I forgot to tell that. That is G equal to, take G equal to 0.8 into G equal to 0.8 into 10 raised to 5 MPa into 10 raised to 5 MPa. He is given the data here. Okay. So G is 0.8 into 10 raised to 5. What is the J? Polar moment of inertia, JP. This is JP, polar moment of inertia, pi d raised to 4 by 32, right? Pi d raised to 4 divided by 32 here. Pi into, what is the diameter of the shaft is given here? The 60 into 60 raised to 4 divided by 32. Pi d raised to 4 divided by 32. So this will be equal to, length of AB is how much? 2 meter, that is 2 into 10 raised to 3. Convert this into in terms of the millimeters. This will be in minus, because here you are getting the minus. Torque is minus. This is anti-clockwise, right? This is clockwise, minus we are taking here. Minus 2 into length is 2, right? 2 into 10 raised to 3, and torque is minus 2 into convert this in terms of Newton meter into 10. This is 10 raised to 3. This is 10 raised to 3. That is 10 raised to 6 into 10 raised to 6 divided by 0.8 into 10 raised to 5 into pi into 60 raised to 4 divided by 32. Okay. Simplify this and calculate the angle of twist of section B with respect to A. After simplification, we will get the answer as minus 0.0393. 0.0393 radians. We'll get radians. Convert this in terms of degrees. Okay, if you convert that, minus 2.25 degrees we'll get. Okay, so this is angle of twist of section B with respect to A. Now similarly we'll calculate the angle of section C with respect to B. Okay, with respect to B. So angle of twist of section C with respect to B equal to length of CB, length of BC. Okay, length of BC into torque of BC, what we'll get divided by same G into JP, polar moment of inertia. Okay, so now if you simplify and substitute, this will be equal to length of BC is 1 meter, that is 1 into 10 raised to 3, 1 meter into the torque BC we calculated here, the minus 1 kilonewton meter. Convert this into Newton mm, 10 raised to 3, 10 raised to 3, 10 raised to 6 into 10 raised to 6 divided by modulus of rigidity is same as usual, 0.8 into 10 raised to 5, and polar moment of inertia is pi d raised to 4 into 60 raised to 4 divided by 32. This won't change, the denominator. Okay, so substitute and calculate, we will get the answer as minus 0.0098 minus 0.0098 radians. Okay, radians. Okay, so convert this into the degrees, we will get minus 0.56 degree. This is degree here. Okay, now what is the third this one here, we need to calculate the angle of twist at section D with respect to C, right? Same apply, the angle of twist at section D with respect to C, so same length of CD into torque of CD divided by the denominator, the G into JP, the polar moment of inertia. Okay, substitute, the length of CD is how much? 1 meter, 1 into 10 raised to 3. Torque at CD we are calculated already, 2 kilonewton meter. Convert this into Newton mm, 10 raised to 3 into 10 raised to 3, that is 2 into 10 raised to 6 divided by the denominator is 0.8 into 10 raised to 5. This is the modulus of rigidity, and pi d square by 4, d raised to 4, pi into 60 raised to 4 divided by 32. Okay, so simplify and calculate the angle of twist at D with respect to C is we will get 0.0197, it is plus 0.0197 radians, that will be equal to, we will get in terms of degrees 1.13 degree, 1.13 degree here. Okay, so this is angle of twist at B with respect to A, angle of twist at C with respect to B, angle of twist at D with respect to C. Now he is asking total angle of twist. So total angle of twist of the shaft is, if you add all these three, we will get the total angle of twist. Okay, so I'll write here, therefore here total angle of twist equal to angle of twist of section B with respect to A plus angle of twist of section C with respect to B plus angle of twist of section D with respect to C. So how much this one? B with respect to A is, we are already calculated here, that is minus 2.25 degree plus here how much it will twist, that is minus 0.56 degree, that is minus 0.56 degree, next plus 1.13 degree. This will be equal to total angle of twist is minus 1.68 degree, minus 1.68 degree. That is total angle of twist. Okay, this is how we need to calculate the angle of total twist here. Okay, so now for the second bit, he is asking maximum shear stress in each section. If you read the problem in the beginning, he's given the maximum shear stress in each section. Here how much, here how much, here how much. That we will calculate now. Okay. Now for this is first bit, and for second bit, what is the formula we can use here? For this one, we can use the formula, the general formula for solid shaft, the torque equation. Torque equal to pi by 16, okay, into tau into dq, right? This is general formula. Frequently we are using here. From this, we can calculate the shear stress in each sections here. Okay. So first I'll write this torque at section AB. At section AB equal to pi by 16 into tau at section AB. I want to calculate tau at section, the maximum shear stress at section AB into dq. Okay. Apply like this. Now torque at section AB, how much here? Just previously we have calculated here. That is 2 into 10 raised to 6 Newton mm. 2 into 10 raised to 6 Newton mm. We calculated before, right? So here before, equal to pi by 16 into, I want the shear stress at section AB into diameter of the shaft is given here 60 mm, that is 60. So now simplify and calculate the shear stress at section AB. Therefore shear stress at section AB in this section equal to 42.7. Okay, 47.2, sorry, this one will get 47.2 MPa or Newton per mm square. This is section AB. Now similarly calculate the shear stress at section BC. What is the formula? Similarly, torque at section BC equal to pi by 16. Same apply this one. Pi by 16 shear stress at section BC into dq. So how much is the torque at the section BC? Before we calculated, just I erased here. At section BC we will get, that is 1 kilonewton meter, convert that into Newton mm into 10 raised to 6, right? Equal to pi by 16 into, I want the shear stress at section BC, diameter is how much is given, 60 into 60 cube. Sorry, here also 60 cube. Okay, 60 cube. Therefore the shear stress at section BC, simplify and calculate, at section BC we will get 23.6 MPa. Okay. So similarly calculate what is the other section remaining here. Remaining section is CD. Calculate here. So I'll apply torque at section CD equal to pi by 16 shear stress at section CD into diameter of cube, its diameter cube. CD how much? Before we are calculated here, that is 2 plus 2 into 10 raised to 6, because it's in kilonewton meter is there, convert into Newton mm. Okay, so if you convert Newton mm, you will get 10 raised to 6 equal to pi by 16. We need the shear stress at section CD, diameter is 60 cube. Okay, simplify and calculate, we will get shear stress at section CD equal to 47.2 MPa. Okay, so this is the second bit. He is asking the shear stress develop at each section. So in the section AB, how much we get here? 47.2. In section AB and CD almost same, 47.2. But in section BC, how much we are getting here? 23.6 here. Okay, so this is the solution for this problem here. Okay, so we are calculated the total angle of twist and total the shear stress here in each sections. Okay.